Okay, lesson 1.1 for Math 2. 6z times negative 5z, negative 30z squared. 6z times positive 2 is positive 12z. 3w over 4 times 8w. So 3w over 4 multiplied by 8w. The 8 and the 4 reduce, giving you a 2. 2 times 3 is 6, and then w times w is w squared. Then 3w over 4 times negative 28. 3w over 4 multiplied by negative 28. 4 goes into 28 7 times. 3w times negative 7, negative 21w. Okay, for each of these we need to decide if it is exponential, linear, or something different, something other than that. In each of these, to get from here to here, we times by 3. To get from here to here, we times by 3. To get from here to here, we times by 3. That's repeated multiplication. Which means that this is an exponential function. It would have a recursive formula starting at f of 0 equals 24. Then f of n would equal 3 times the previous value, f of n minus 1. It would have an explicit formula of f of n equals the 24 that we started with multiplied by 3 to the n power. Okay, this one, from here to here, we add 1. From here to here, we add 3. From here to here, we add 5. So we're not adding the same number every time. From here to here, we times by 2. From here to here, we don't times by 2. So we're not multiplying by the same number every time. So this one is something different. The recursive formula here can be a little tricky to figure out. The explicit is fairly simple. We have f of n equaling, if we look at this number, 0 squared plus 1 is 1. 1 squared is 1 plus 1 is 2. 2 squared is 4 plus 1 is 5. 3 squared plus 1, 3 squared is 9 plus 1 is 10. So it's n squared, add 1 to the answer for the explicit formula. I could tell that it would have an n squared because these numbers, this first level differences, these are the first level differences, are increasing by the same amount every time. That means that it's going to have a squared in it. And so I looked at the perfect square numbers and compared them with what was here. 0 squared, 1 squared, and then I saw that I had to add 1. We'll wait on the recursive formula on that one. Okay, over here on this one, we have plus 4, plus 4, plus 4. Since we're adding the same amount, that's repeated addition. Which means it's linear. It would have a recursive definition starting with f of 0 equaling negative 12. Then you could get f of n by taking f of n minus 1 and adding 4. And then the explicit definition, f of n, starting with negative 12, we're going to add 4 for each n. negative 12 plus 4n. The next step on this was to graph each of these. If you make a graph for this, it's going to go up like this. If you make a graph for this one, it's also going to curve up, just not quite as drastically as this one does at the end. And then if you make a graph for this one, it is going to make a line. It'd be coming up like this. So the word linear, this is quadratic and this is exponential. We will talk more about those in the future. Okay, now we want the rate of change. Rate of change is slope. So in this diagram, I find the point where it crosses, and I can count up 1, 2, 3, 4, to the right 1, 2, 3. So the rate of change is 4/3. Up 4, right 3. Rise over run. This one, we're adding 2 every time. Or I'm sorry, we're subtracting 2. And we're going up 1. So rise over run, so negative 2 over 1, which equals negative 2. This one, rate of change, this is y equals mx plus b. The rate of change is the slope. This one is a recursive formula, so the rate of change is the common difference. And this one is 2 points. We have to find the slope. So the change in y, 7 take away negative 5, over negative 6 take away 8, giving us 12 over negative 14, which reduces to negative 6, 7.